All right. Okay. Thank you. So my presentation is going to be on the root zone DNSSEC key signing, key rollover. So it's a kind of long topic, and I'll just try to give a very brief introduction, and then just in case if you are new to DNSSEC and new to these keys, so these are just brief introductions so you know what we are talking about. First of all, now the objective of this presentation is to focus on few things. That is to publicize the root zone DNSSEC key signing key. So as I said before, there are some terminologies that we use here. So we have this security mechanism, DNS security mechanism called DNSSEC. Probably most of you know that. So just in case if anyone is new to DNSSEC, so it's a security mechanism to protect the DNS data, right? In fact, the previous presenter, Eric, went through quite a lot on the DDoS side of it as well. So here we are talking from a data or DNS data protection perspective. Things like cache poisoning or things like DNS hijacking and so on. Simply, you know, if you see a DNS query, the client would send a DNS query to a resolver, and then the resolver would go to a root server, and then the root server would give a referral to the next level, which is the TLD, and then the TLD, the recursive server will go and talk to the TLD servers, and then that would give a referral to the next level, and so on, and then finally the recursive server will get the answer and return it to the client. So in this whole process, the recursive servers or the resolvers, they keep this data in their caches. So the cache poisoning can happen, so the wrong answers can get into the caches. So here, it's very important to protect these sort of security situations or threats related to the DNS. So that is where we are coming from. So there are lots of attacks nowadays, phishing type of attacks and so on. So that's why it's quite important for us to protect our DNS data. So what we are trying to do here is actually we try to sign our zones. So in DNSSEC, we try to sign our zones. So when we try to sign our zones, obviously, you know, we use cryptographic keys. So we use these asymmetric keys. So we have private keys and public keys. So once we sign our DNS data, what we do is we sign the resource records or the resource record sets in our zone. And then, so we have these signatures. So these signatures can be validated by the public keys. So when you talk about, say, a particular zone, now once you sign, now this, so you have protected yourself, you have secured yourself, but that is not really enough because in DNS we have a hierarchy. So the hierarchy is that we have the root, and then we have the TLDs, and then the next levels, and so on. So if, say, you are a second level zone, and then if you protect yourself, you have to then propagate this trust to your parent. So once you sign yourself, you propagate this trust to your parent. So how do you do that? You do that using basically, you know, we have these other resource records called DS records. So we send our DS record to our parents. So simply this DS record is actually a hash of our public keys. Now talking about the public keys, this is where these terminologies would come in. Now there are two types of keys we talk about. One is something called the zone signing key, and the other one is what we call the key signing key. So zone signing key, or ZSK, we used to sign our, that's what we use to sign our own zone, right, the zone data. And then we sign the ZSK using another key called a key signing key, or the KSK. So what we send to our parent, what I mentioned to you before, the DS record is actually the hash of our key signing key, or the KSK. So this process has to happen all the way from your parent to parent's parent and so on, and then this trust would go all the way to the top of the DNS hierarchy and end up in the root. So this is why the root keys are very important, because root has to be trusted, because all that trust would go up and then end up in the root. So the root keys are quite important. So the root also has got these zone signing keys and the key signing keys. So here this whole presentation is focusing on the root's key signing key, because this key was generated back then. For the last 6 years we have been using the same KSK for the root has started, and that is why we want to actually keep you updated with this process so that you can actually update your resolvers in terms of validating these keys. So that's the whole purpose of this presentation. Okay, so as I said before, the KSK, now you know about KSK. So the trust would go all the way. So if you are talking about your own zone, so you have your own ZSK and then KSK. So you send the hash of your KSK to your parent as a DS record in DNS, and then parent would put that DS record into parent zone, and then parent would sign it, and then parent would send the parents or the hash of the KSK to parent's parent, which is all the way go up to the root, right? So that's what we are talking about. So when the DNS query gets resolved, when the recursive server goes and talks to these root name servers, the TLDs, and so on, these things can be validated, because the root would send the DNS key or the resource record related to the public keys, and then the signatures, and then it can be validated, because the recursive server has to have some other means, the root keys, so that it can validate whether it's the correct key. Okay, so now what's happening, as I mentioned you before, in 2010, the KSK was generated, right? The KSK was generated, and this was called the KSK 2010, if you see the terminology of this presentation. So when I refer to KSK 2010, that is the key signing key, which was generated back in 2010. So since 2010, before the 2010, there was nothing before, because the root zone was signed in 2010, and since after the 2010, we have been using the same key. So the new key that we are going to talk about now is highlighted here as the KSK 2017, which is actually now the process has started. It has begun late last year. The key generation has started, and this process or this project will continue for pretty much another 1 year or so. Now, if you are an operator, especially because if you are a network operator, if you are an ISP, because you would be running your recursive servers, because you are providing recursion to your clients, your customers, and so on. So when you get those recursive queries from your customers, and if your recursive name servers are validating or giving DNSSEC enable answers, then you have to know about these key change, because you have to validate these answers based on the new root KSK, right? Okay, so what you will need to do is basically, if you are an operator, you will need to review your configuration, and then just make sure that the new KSK is updated. Now here we have to actually think about few important milestones or the dates. So that's where you need to be aware of. So these are actually the main dates that we are talking about. So as I said before, the creation of the KSK, the 2017 KSK, that has happened in October last year. So that has happened, and then also actually these keys are being kept in 2 key management facilities. So it has also been taken from one facility to another facility as well. So it is now production qualified. That has happened in February 2017. So the key, it's all production qualified now. Now, what is happening at the moment now, it is the out of DNS band publication. That is also why we are doing, this kind of presentation here. And also so that we are publishing the root key, the KSK now, so that you know about it. And it is also actually, I put that into the slide as well. So that is the root KSK. And so there are various ways that you can get this root KSK. So that's what's happening now. And then the in-band, so which is the automated updates or the automated publications, that will happen from July 11, 2017. That's this year, that July 17th onwards. Now, the signing, so which means, the signing using the new KSK, so that will happen on October 11. So these are the most important dates, actually, because the validation will happen based on the new KSK 2017 from October 11, 2017. So that's the most important date here. And then the revoking of the KSK 2010, that will happen in January 2018, and then later on, around next year or so after that date, the 2010 KSK will be removed from the systems. Okay, so just to show you, recognize, so that you can recognize what are we talking about here with KSK 2017. So that's the DS record. Above you can see the key tag. So the key tag is 2326, that's the key tag. And then below you see the DS record. So that's a resource record. So DS is the delegation signer. As I mentioned you before, that's a hash of the KSK. That's a hash of the KSK. And so you can see the label is the root, and then you have the resource record type is the DS. The key tag is 2326. And then that's your DS. And also actually the DNS key resource record, that's also a resource record. Now DNS key resource record we use to publish our public key, or the KSK here. So that is also a resource record, and DNS key is the resource record type. When it is KSK, when it is KSK, you'll see 257, the flag, because usually, like when you see 256 flag, that's the zone signing key, whereas when you see the 257 flag, that's the key signing key. There are a few other flags over there, like 3 is for DNSSEC, and then 8 is the algorithm that has been used to generate. So the rest of the part is actually the KSK, the public key, right? So even if you want, you can still copy using these slides if you trust that. So that is the new 2017 root KSK. All right, so why there are DS and DNS key? Because we talked about two resource record. One is the DS and the other one is the DNS key, because DS is the hash of the DNS key, and depending on different tools that are being used, some of you could be using either of those depending on the situations. Okay, now the current state of the system. So we call it sunny day scenario, right? Because it's all done in good conditions, like under good conditions. Because it's not that something has been compromised as such. It's not that the root key has been compromised. So it's all done as a best practice, because it has been used for 5 or 6 years or so now, and there has been a DNS practice statement where compromise has happened. So there are some recommendations in terms of doing this. You can do this automatically, or the changing of the KSK. You can do this as automated updates, or this can be done manually. Protocol, that is the RFC 5011. So if you want to do it automatically, you can still follow the RFC 5011. So this is just to mention you about those dates in a calendar format. If you are talking about the key dates here, so July 11, 2017. That's where the new KSK, the KSK 2017, will appear in the DNS. And then August 11, 2017. That is like 30 days. it will be there until it can be trusted. That's how the RFC 5011, it works out. There's a 30-day period that it trusts after, because after the 30 days, that can be trusted, right? So that's 11th of August 2017, and then later on 11th of October 2017, that's where the signing will start happen. So these are all the details of those dates that we mentioned about. So I just mentioned those dates. July 11th, based on RFC 5011, it will start counting days from July 11th. So August 11th is 30 days. So after 30 days, it will be trusted. And then, so after that, on 11th of October, the key goes live, and it is already been signed, and the key goes live, and then the validation will happen based on that. So now, in case, say, after August 11th, right? So that's where the automated updates, if you are doing automated updates, your system should be trusting that after 11th of August. But in case if it's not working after 11th of October, don't get panic or anything, right? Just check, what's going on, whether if there's anything wrong, whether the automated updates are not happening, and so on. So, but you still have about 2 months or so from 11th of August until 11th of October for you to do that testing, right? Okay, why these automated updates in use? Because many DNSSEC validation tools, they have RFC 5011 support built in. That's why, it's a kind of preferred way. It is kind of a recommended way. But then it is also actually, if you want to do it manually, that's fine as well. It's not actually a must to do always automated updates. You can still do it manually. And also, actually, there are different ways that ICANN is publishing the KSK 2017, so that, if you're doing it in manual ways, you can also actually do that manually. There are choices, as I mentioned you before. It is depend on organizational policy, what you have, whether you want to do automated updates or whether you want to do manual updates. So it all up to you actually in your organizational policy. Now, if you're doing DNSSEC validation based on the KSK 2010, you can simply follow the automated updates, because you have already a trust anchor, and then when the new one comes in, it will start trusting the new anchor, which is the 2017 one. Now, if you are establishing the trust in the new one, which means like the manually, if you are trusting that, not the automated updates, if you are doing it manually based on the KSK 2017, there are a few ways you can do it. One is that there is a trust anchor XML file, so that is the link for that, so you can get it from there. So that is one way of doing that. There's also actually a root anchor detached signature also. You can verify that as well. That is one way of doing it. Another way is actually you can do it through DNS. So which means you can query the root, and then you can query for the DNS key resource record, because as I said before, we use the DNS key resource record to publish the root KSK. So you can do a query through DNS and get the root KSK through DNS as well. And then there are other means also. The other means are that some of the software or the OS distributions of DNSSEC and so on, they could be embedding these KSKs into their systems as well. So that's another way they could do that. So you might want to actually be in touch with the distributors of your software and the operating systems. As I also said, actually, the keys are in this slide set as well. So if you trust the slide set, you can still copy it from the slide set also. That's another option. And also, there might be various other ways. Probably, maybe it could be printed in different trinkets or maybe T-shirts. All right. So. So call to action, what you have to do is, if you are an operator, developer, software distributor, and so on, be aware of this, right? So the you have to do DNSSEC validations, because if you are going to give DNSSEC validated responses to your clients, this has to be done properly. But what about if you are just an internet user? Also be aware of it, because currently, based on the estimates, currently about 750 million internet users use these DNSSEC validating resolvers to actually get the responses. So that's a quite big number, right? So if the resolver is not really validating, then they can't really get to the place, so the server fail, and you can't get the server, right? Or you can't get to the place. So this is why, especially as an operator, you should be thinking about this and providing that service to your clients. There are lots of information that you'll find in ICANN website as well. So all these processes have been defined. There are lots of resources for developers, distributors, operators, and for everyone, actually. There are lots of information resources available. So important bits, as an operator, be aware whether actually you are validating based on DNSSEC, right? That is quite important, because in case if you are not sure, you might want to check whether are you really validating based on DNSSEC. And also actually whether how the trust is being evaluated in your operations, so that's something to verify. And then also actually verify your setups, because depending on different versions that you use, sometimes the configurations can be different as well, because some of the previous versions could be having different statements to update these trust anchors and so on. So depending on the versions, you might want to check whether it's the right way to do it, whether it's the right file to do it, and so on. Yeah, also actually have some planning for this whole thing, and know the dates what we talked about, and then be aware of that. So these are some just some snapshot of validation, DNSSEC validation enabled tools out there. So these are all these tools. If you're using these tools, they're doing DNSSEC validations. Now, in case if you get some problems, there could be some problems in these areas. One is that, IPv6 fragmentation related issues, because as you may know, in IPv6, the fragmentation happens in the source, and then the assembly happens in the destination, not really in the network. So for large packets, because here we are talking about quite large packets, and because the size is quite increased, so there could be, if there are some fragmentation happening, you might have to check on this as well, right? So because in UDP that cannot be handled, so you might want to allow actually TCP in this case. So anyway, actually now in DNS, making sure that you are allowing TCP is good, especially when you deal with DNSSEC. And also, just double check whether your trust anchor is correct. In case if you have a wrong trust anchor, that can create issues, as we discussed. So these are some resources for you to do some testing. So we have put some resources where you can check the size of the messages as well, and test and verify that you can receive these large DNS key sets. So if you go to these URLs listed here, you can test whether you can pass this from your network. And also, as we discussed, TCP should be a permanent fix, not just a temporary fix. But in case if something happens, say after you started this, if something happens, best option is actually if the clients can't get to these required places, you will get a lot of tickets, right? So they'll call you, they'll send you tickets, they can't get you to these places, and make sure that probably at least for a temporary basis, stop those tickets until you do your debugging and so on. So what you can do is you can turn off the DNSSEC validation until you do the debugging, and once you fix it out, then you make sure you turn on the DNSSEC again, right? So that's quite important. And then you do the test and recovery. So as I also mentioned you, there are some few resources, and there's also actually a Python language script if you want to retrieve this new key. And also automated updates. There's a test bed where you can check on the automated updates, and there are quite a lot of documentation available in this given URL in the ICANN website. I think this is all what I wanted to quickly update given the limited time we have. If there are any questions, I can take anything very quickly, or I'll be around here during the afternoon as well. Feel free to talk to me during lunchtime. Thank you.
Thank you, Champika.